Welcome to aminacademy.com. In chemistry, let us discuss about stoichiometry. What is stoichiometry? Stoichiometry in chemistry is the determination of the proportion in which the elements or compounds react with one another. The rules followed in the determination of stoichiometric relationship are based on the laws of conservation of masses and energy and the law of combination of weights and volumes. Here, balanced equations shows the proportion of the substances you have to mix to make a preferred compound. For just, you can interpret the equation in which the particles, you can interpret them in terms of moles. Suppose then balanced equation is given, that number of particles required is also directly related to number of moles of each substances. Here, look at this equation. For example, 2C8H18 plus 25O2 gives 16CO2 plus 18H2O. This equation shows 2 molecules of C8H18 and 25 molecules of oxygen O2 gives 16 molecules of CO2 plus 18 molecules of H2O. Because of Avogadro's number links molecules to moles, here we can convert this as number of moles itself. That means we can understand this 2 moles and 22 moles of C8H18 and 25 moles of oxygen gives 16 moles of carbon dioxide, 16 moles of carbon dioxide and 18 moles of water we produce. That means by adding 2 moles of C8H18 and 25 moles of O2, which gives 16 moles of carbon dioxide and 18 moles of water. Here the equation shows this moles combination. In this chapter we can learn to determine how much of a reactant is needed to produce a given quantity of product. The branch of this chemistry that deals with quantities of substance in chemical reaction is known as stoichiometry. We study about how much reactant needed to make particular products, particular number of moles of product. This study is stoichiometry. Here the mole ratio is the main key point. If you normally buy a lunch at school, normally it's each day, how many times would you need to buy some extra things to make that meal as a full satisfaction or full meal in need. Normally the coefficient in a balanced equation shows the relative numbers of moles of the substance in the reaction. As a result, we can use the coefficient in conversion factor called mole ratios. Mole ratio bridges the gap and can convert from mole of one substance to moles of another substances. Here consider mole ratio here. Consider the reaction of the ammonia preparation. Suppose here, look, here the equation says N2 plus 3H2 gives 2NH3. This is a balanced equation. Here we need, suppose this is equation, how many moles of hydrogen are needed to prepare 312 moles of ammonia. Now this, from this equation, the question is how many moles needed. Moles of hydrogen. Then needed to make, to prepare 312 moles of ammonia. Look at this by ratios you can do. Here this equation is N2 plus 3H2 gives 2NH3. That means 1 mole of nitrogen and 3 mole of hydrogen makes 2 moles of NH3. In this equation, following this equation, how many moles of hydrogen needed to prepare 312 moles of ammonia? That means gives, look at NH3 equal 312 mole. H2 is how many moles? How many moles we need? That means here the mole ratio must cancel out each other. Look here, 3 mole of hydrogen. From this equation, 3 mole of hydrogen, 3 mole of H2 over 2 mole of NH3. Therefore, this is the equation. Then therefore H2, how many moles, number of moles of H2 gives 300 mole of NH3 into 3 mole hydrogen and 2 mole NH3. 2 mole NH3. So from this equation, this moles are correct. Then you can say that numbers you can use it. Only 312 into 3 over 2 is 156. 156 into 3 is 468 mole of H2. That means we can say 468 mole of hydrogen needed to prepare or make 468 mole of hydrogen we need. To prepare NH3, prepare ammonia. This study deals with stoichiometry of chemistry. That means one mole amount is given, other mole amount we can find by using stoichiometric ratios. Now we can solve the problems involving mass, volume or particles by using stoichiometric rules. For mass calculation, use molar masses. The conversion factor for converting between mass and amount in moles is the molar mass of the substance. The molar mass is the sum of atomic masses from the periodic table for the atoms in a substance. Then from that we can find it molar masses of each substances involved in stoichiometric problem. Notice that the problem in 3 steps process. The mass in gram of the given substance is converted into moles. Next, the mole ratio is used to convert into moles of the desired substances. Finally, this amount in moles is converted into grams. Here, in future videos, we can do some example problem of finding ratios of the required ratio of each substances by using stoichiometric methods. We have done. Please subscribe our YouTube channel.